Okay, today we're going to learn about solving radical equations. That's what we're going to be doing. Whoa, what's a radical equation, dude? Well, I'll tell you. Here's what it is. It's an equation that has a radical in it, right? What is a radical? A root. We're solving equations that have roots in them. Not just that have roots in them, we're solving equations where the variable is located under the root. So notice, every single one of these, as we're going to go do them, see how the variables are underneath square roots? Those are called radical equations. Here's how you solve radical equations. Now, we have to understand what inverse operations are. Like for instance, addition and subtraction are inverse operations. If you take a number 10 and you add 5, that gets you 15. Then you turn around and subtract 5. It gets you back to 10. Because adding 5 and subtracting 5 are inverse operations. They undo each other. That's what inverse operations do. Just like multiplication and division undo each other. Well, when we're talking about radicals and square roots, what undoes each other is squaring and square rooting, right? So raising to the second power and square rooting, they undo each other just like adding and subtracting and multiplying and dividing do. So, here's the deal. Here's what you do. Say you're bopping through the forest, and you happen to see a guy saying, see a guy laying there, and there's a tree on top of him, and he says, "Help! Help! I'm trapped under a root and I can't get up." And you look at him and say, "Well, what do you want me to do?" He says, "Could you please lift that root off of me so I can get up?" And then you say, "Why, yes, I can." And so you go and you lift the root off of him, and then he comes up and he says, thank you. By the way, my name's Bill Gates, and here's $1 billion for saving my life." That could happen. So I would pay attention to what we're learning today. Okay, here's the thing. So let's say we're bopping through the mathematical forest, and holy moly, what does X say? "Help, help, I'm trapped under a root and I can't get up." So what do you say? Wait, how can I lift that square root off this poor guy? Well, I can do the inverse operation. I can square, right? But it's an equation. If I square this side of the equation, I have to square this side of the equation. So that whatever you do to one side of the equation, you got to do the same thing to the other, right? It's like a scale, like a balance, okay? So this wipes out the square root, and I get 4x equals 6 squared is 36. Now, to get rid of, hey, how do I undo times by 4? I know, to undo times, you divide, right? Divide by 4. Aquí está 9. Now, that you might say, that's my answer. And I say, no, that's not your answer. That is your potential solution. Because it is possible. Here's what you need to understand. It is possible, whenever you square both sides of an equation to get rid of a root, you are potentially introducing bogus roots into the situation. You may do everything correct, and your answer may not work. So what you have to do, you have to go back before you ever squared both sides to the original problem and plug it in and make sure that your answer actually makes it a true statement. If not, it's a bogus solution and you got to throw it out. So here's the deal. Plug in 9. 4, I'm going back before I squared them. I'm just doing the original black equation here. So 4 times 9 is 36, right? Square root 36 is 6 equals 6. Sure enough, it works. It is a good solution. So it was a potential solution. Now we know it's a good solution. That's not always the case. Sometimes they don't work and you got to throw them out. Okay, this guy. Now, you might look at this guy and look what X is saying. "Help, help! I'm trapped under a root and I can't get up." But guess what? You might be thinking you're the nice guy. Don't write this down if you're taking notes, which is a good idea. But here's the thing. You might say, "I know, I can just square both sides." That is not what you want to do. This is not what you want to do. Why? Because remember, this is like a binomial. So it would not just be square root x. This wouldn't just be x plus 9. You would not just square this guy and square this guy. You would have to FOIL it out and it would not even get rid of your root if you had to FOIL it out. So you could do this, it wouldn't be wrong to do this, but it would leave you with something uglier than what you started with. So you don't want to do that. This is very important. What you want to do is get the root, get the radical completely by itself. You don't want the +3 stuck onto this guy. You want, see how the root was by itself over here? That's what we want. We don't want a +3 stuck onto it. So how do you do that? Well, what if this was just a big X and I was trying to solve for it? You would -3 from both sides. So now I get square root X equals 10 to the 3 is 7. Now the radical is by itself. Now square both sides of the equation and you get X is 7 squared is 49, which is my potential solution. Let's see if it works. Plug it back into the original black equation here, right? Square root 49 is 7 plus 3 equals 10. Checks out. It's a good solution. There you go. Okay? This guy. Oh my gosh, good news. The radical is already by itself. Look, there's nothing stuck onto it like the +3 was stuck on there. This -5 is still underneath the root, so this is all one root. So I'm ready at this point to square both sides. So that's going to give me just X minus 5. Nice. Square root of this whole thing squared is just this thing equals 4 squared is 16. Okay. Plus 5 plus 5. X equals 21. And let's see, whoa, I almost put a box around it, but shame, shame, shame on me because I did not check to see if it was a good solution yet. Okay, 21. 21 take away 5 is 16. Square root 16 is 4. 4 equals 4. Yep, checks out. It's a good solution. Cha-ching. Okay, let's keep going. All right. Oh my gosh, what happens if I try to square both sides here? See how this -4 is not under here? That would make this a binomial. I'd have to FOIL it out and I would get an absolutely ugly, ugly, ugly thing. I don't want to do that. So how do I make it much, much easier on myself? Get the radical by itself. Get rid of minusing 4 by plusing 4. That gives me root 2x plus 1 equals 7 and 4 is 11. Much nicer. Now I'm ready to square both sides. So it's going to give me 2x plus 1. This whole root thing squares, cancels, gives me that. Equals 11 squared is 121. Okay. And then, let's see, I'm going to -1 from both sides. And I'm going to get 2x equals 120 divided by 2. X is 1 times 60. 60, which is my potential solution. Put in 60. 2 times 60 is 120. Plus 1 is 121. Square root is 11. 11 take away 4 is 7. So it's a good solution. Cha-ching. Okay. Let's see about this guy. Gee, square root x divided by 3. How do I get rid of divided by 3? Well, remember, what's inverse operations? Multiply is the inverse of divided. So I'm going to multiply by 3. That means I have to multiply this side by 3. Whatever I do to one side, got to do to the other side. These guys will cancel because I designed it that way. I times by 3 to cancel that 3. Root x equals 15. So I had to, help, I'm trapped under a root and I can't get up. That's fine. I'll just square both sides. And I'll say x is 15 squared is 225. Oh, whoa, shame on me, shame on me. I didn't check to see if it, this is only a solutionalis potentialis right now. So let's see if it works. Square root 225 is 15, divided by 3 is 5. Cha-ching, I was right again. In fact, Wait a minute. Every single one of these has worked. I think that dirty dog Ferrari's lying to me about all of this, this stuff having bogus solutions. I didn't see no bogus solutions. I don't know. I think that Ferrari might be a liar. Well, we'll find out. Let's see. Okay. Wow. Look at this. It's already by, oh my, this cannot be this easy. This must be like some animal coming by in the forest and someone's laid out some food for them. Like, this looks too easy. Like, can I just, and then they go eat the food and they fall in the trap or whatever. So no, it's like, did someone set a trap for me? Because this looks so easy. Look at this. Square this and square this, and I just get no way. X plus 1 equals 3. Can that possibly be right? Yep. Okay. Then, no way. Minus 1, minus 1. So we get X equals 2, baby! 2! Woo-hoo! Which is my solutionalis, potentialis. We got to see, does it work? Because that Ferrari's saying sometimes it doesn't. Is he lying? Let's see. 2 plus 1 is 3. So this is square root 3 equals square root. Oh my gosh, it works. I don't know if that Ferrari knows what he's talking about. Well, we'll find out because I got a couple more problems to go. Okay, so let's knock out those. Can you keep going for a couple more? With your arm and everything, yeah?
Go
okay.
for it.
Okay, all right. All right, so here we go, here we go. They get more fun as we go along. Okay, here's the next one. Root 4 plus x equals square root 5x minus 4. Okay, this is kind of like the other one. They both have square roots. Look, it can't, wait, there's got to be a trick here. It can't be that easy, but it is. Oh my gosh, this is like we learned like chapter 1 or whatever. It's really, or chapter 2 in our book, something like that. It's crazy. Look, move the x's over here, cancel that. If I'm moving the x's over here, might as well move the number over here. No way, it can't be that easy, but it is. 8 equals 4x, divide by 4, x equals 2. Is my solution? No, my potential solution. Let's see if it works. 4 plus 2 is 6. Square root 6 is square root 6. Notice I'm going before we squared both sides, right? Let's try 5. 5 times 2 is 10, minus 4 is 6. Square root 6. Square root 6 equals square root 6. Sounds good to me. Okay? Hang in there. 2 more problems. Okay? Hang in there. Root 2x plus 5 minus 1 equals x. This is probably the hardest one we're going to do. Right here. Okay? Hardest one we're going to do. Here's what you do not want to do. You do not want to square this guy. I hope you're getting that idea. Look, because of this minus, let me just show you, if we were to square this guy, this is what we would have to FOIL out, just so you can see why we do not want to do this. And we would have to FOIL that out. This times this, and then this times this, this times this, this times this. It would be an absolute nightmare. That's why you do not want to square both sides right now. What you want to do instead is get the radical by itself. Get the radical by itself, okay? So what do? Add 1 to both sides, okay? By the way, we're stepping it up a notch at this point. This problem is harder than the other ones we've been doing. Look what we got. Radical by itself. Good news. So now I'm at a point, since I have the radical by itself, now I'm at a point where I can square both sides. But notice, wait a minute, that means I'm going to have to FOIL this thing. Look, x plus 1, this is a binomial. I'm gonna have to FOIL this thing. Yeah, well, it's better than FOILing out that other thing that I had written here, definitely. So, hey, if you have to FOIL out something, I'd rather FOIL out x plus 1 rather than root 2x plus 5 minus 1 squared. I'd rather FOIL that guy out. And that's exactly what I'm gonna do. I'm gonna FOIL this guy out by going x plus 1 times x plus 1, right? That's what that's, this is clearly just gonna be 2x plus 5, right? The root gets wiped out by the squared equals, now, what's this guy gonna be? X squared plus x on the outside plus x again on the inside plus 1. That's gonna be, hang on, x squared plus x, and x is 2x plus 1. That's what you get if you FOIL this guy out. X squared plus 2x plus 1. Now, how do I solve an equation like this? Here's how I solve an equation like this. Whenever there's a squared or higher, you want the other side to be 0. You want it, the thing in front of the square term to be positive. Okay, it is already. That means you wipe out the other side over here by doing this. You got to make one of the sides 0, and you want your highest powered variable, oops, 20, why did I put 25x? It's minus 2x. Minus 2x, minus 2x, and then I'm going to minus 5, minus 5. Remember, my goal is to wipe out this side and leave a positive in front of my square term, and I get 0 is x squared. These guys cancel, minus 4. Oh my gosh. Now, you guys should know how to factor that. In fact, you should notice one thing. It's a dog. Or you might notice, gee, my leg's getting warm because there's a dog peeing on it that I didn't recognize, right? So hopefully you recognized it and said, hey, it's x plus 2, x minus 2. You should know this. This should not come as a surprise to you. We talked about this over and over and over, okay? So x is, now remember, when we're solving, when we factored a polynomial equals 0, x is opposite of this over this, negative 2 over 1, which is negative 2, and positive 2 over 1. Change the sign, this over this. Positive 2 over 1 is positive 2. Those are my potential solutions. Now notice, there's 2 of them. So I need to try them both and try them separately. So let's start with negative 2 to begin with. Okay. Now notice, don't go here, don't go here, don't go here, go here. Go way back before you ever squared anything. Go to the beginning right here. That's where you plug it in. So if I plug in a negative 2, I'm just doing negative 2 right now. It becomes 2 times negative 2 plus 5, right? Minus 1 equals negative 2. See, I put negative 2 in for x and negative 2 in for that x. That's going to give me negative 4 plus 5 minus 1 equals negative 2. And then square root 1 minus 1 equals negative 2. Square root 1 is 1. 1 minus 1 equals negative 2. Wait a minute. 1 minus 1 is 0. 0 equals negative 2. Let's see. If I have $0, is that the same as owing somebody $2? I don't think so. No. So wait a minute. That makes this one a bogus solution. It was a potential solution, but it's bogus. Wait a minute. Weren't you just saying that you thought Ferrari was lying because none of them ever turned out to be bogus? They all worked. Now we found one that didn't work. I think you owe me an apology. I'm waiting. Okay, thank you, thank you. Well, now, they can be bogus, right? What did I do wrong to get negative 2? I didn't do nothing wrong to get negative 2. That happens. Sometimes when you square both sides of an equation, you can get bogus solutions. That happens. That's why you got to check them. Okay, now, what about this one, too? 2 times 2 is 4, right? Plus 5 is 9. Square root 9 is 3. This is 3. 3 take away 1 equals 2. Yes, 3 take away 1 is 2 equals 2. Yes, that one is a good solution. So there's the answer. There was 2 potential solutions. This one's bogus, so the actual answer is only x equals 2. If you put x equals 2 and negative 2, that would be wrong, because negative 2 was potential, but it turned out to be bogus. All right, one last final problem. Here it comes. Get ready. The grand finale. Okay, here it comes. It is called, I don't know what it's called, but here's what it is. Square root x minus 2 equals 2 minus x. That's an interesting problem. Yeah, we'll find out what it is. Okay, here we go. One good thing happens. This guy's already by itself. So holy moly, I don't have to move nothing around. Just square both sides. And something beautiful happens right here. X minus 2. Oh my gosh, can it be nicer than that? I don't think so. But what happens over here is I have to go 2 minus x times 2 minus x. That's what squaring does, right? And then I will get x minus 2 equals, FOIL this out, 2 times 2 is 4, minus 2x, minus 2x, minus x times minus x is plus x squared, okay? Now, what I'm gonna do is, I see how my x squared's positive, right? I want that, I want positive in front of my square term. That means I'm gonna wipe out el otro lado, this side over here, right? By going minus x, plus 2, and let's see what I got. Now I know, since I designed it this way for these to cancel, this has to be 0, equals, start with the highest power, x squared. Now, look at these guys. There's all the x terms. Negative 2x and negative 2x is negative 4x. Negative 1 more x is negative 5x. And then 4 plus 2 is 6. So there is my trinomial that I need to factor. Now be careful. This actually is a nice one because x, there's two ways to multiply to be 6 and to give you 5. Notice 6 and 1 subtract to be 5, and 2 times 3 multiply to be 6 but add to be 5. How do you know if you use 2 and 3 or 6 and 1? You go here, remember, they need to multiply to be this guy and do this, add to be 5. Which numbers multiply to be 6 and add to be 5? It would be 2 and 3, not 6 and 1. If this were a minus, then you would use 6 and 1, but it's a plus, so you use 2 and 3. So 3, 2, same sign, both negative, boom, boom. Now, that gives me x is opposite this over this. Positive 3 over 1 is positive 3. Positive 2 over 1 is positive 2. Those are my two potential solutions. Let's see if they work. Let's start with 3. 3 take away 2 is 1. Square root 1 is 1. This whole side is 1 before you square it, right? Equals 2 take away 3 is negative 1. Now, 1 equals negative 1. Is that true? No, that's not true. That makes 3 a bogus solution. Okay, I'm waiting for the apology. Okay, thank you. And then also, number 2, or let's try number 2. 2 take away 2 is 0. Square root 0 is 0. So yeah, so this is 0, right? Equals 2 take away 2 is also 0. So 0 equals 0. Yeah, that's true. So 2 is a good solution. So there you go. There was 2 potential solutions. One of them turned out to be bogus. So 2 is the correct answer. All right. So that's it. That's solving radical equations. Here is the homework. I'm going to change over to the homework. Cha-ching right there. Homework number 44, page 726, 7 to 39 odds. Enjoy yourself.